All right. I don't have a whole lot. I just want to do a little bit of problem solving after a little bit of review here. So you have a new formula, all right? When we're talking about Newton's second law, it mainly, let's say, refers to that formula, that a force equals mass times acceleration. That's kind of where, this is something that I told your sister's class as a joke. I down that work makes you angry or it makes you mad. That's what these formulas in physics deal with. When you replace equal values, that work equals mad. So, does work make you angry? Work make you mad? It does. Why is that? Because you have to do it? Yeah, sometimes it's frustrating. Okay. Dealing with young men and women, that's what I'm talking about. Should it make a person angry?
Yeah, sometimes.
So, because maybe we've got future teachers out there that want to deal with people your age right now. Only thing is you're 10 years older, but you're dealing with people your age right now. Would you want to do that? What are we saying no for? Then you're saying that you are? Are you? No, I don't want you to be. I really don't think. Is there issues in here? I haven't seen any. So. Oh, well, we can certainly do attitude adjustments pretty quick with that. Moving forward then, what we want to discuss then, well, how do we know what it is that we're dealing with? Well, with this Newton's second law, okay, the standard measurement for mass then, as you can see, is in kilograms. It can be in grams, but then you have to convert that to kilograms. Okay, and as we know, acceleration is measured in meters per second squared. And sometimes you use gravity, sometimes you don't. It depends upon what it is that you are dealing with. If it's no other forces acting on it, then you would use gravity. But if there are other forces like air resistance or different types of friction, well, then you would not be using 9.8. And this was years ago. Given an exam down in a school I used to work at, and young ladies reading the problem. Oh, good, the head chop thingy. What do you think a head chop thingy might be? A guillotine. Does anyone know what a guillotine? If you're saying guillotine, you probably know what it is. But does anyone not know what a guillotine is? Okay. When with the seniors, I was reading. We take time out. We call it Today in History. Of course, it's going to change from year to year because you're always going to be adding new stories to this. But I want to. I can't remember what day that was this week. But it dealt with the Spanish Inquisition. Has anyone ever heard of that before? I don't know why you would have, but what it was I want to say a religious movement back in Spain, somewhere around the 1300s, I believe, that, if my history is correct, it was people, if you don't make your conversion to Christianity, you get executed. Okay? Now, what could that be? Maybe burned at the stake, maybe beheaded, uh, maybe one of the worst. And all of them are bad. Don't get me wrong. But what about the rack? Anyone ever heard of the rack? No, I don't think you call that. I don't know that different name. But a rack is where you're strapped down on a table, probably longer than this, probably longer than 8 feet, and you had a rope tied to each one of your limbs, okay? And then one of the thing, yeah, you're stretched out, and a winch starts to get turned and starts to pull you apart at your joints. Eventually, it's going to be one of them things you're going to try to, I don't know, it's not that you're going to say, oh gosh, finish me now, because you're being executed. But now, we're not bringing this up just for fun. This is something that has happened in history, okay? But one of the things that it would do, it would probably pull your shoulder joints out, your knee joints, and your hips, and eventually just probably pass out from the pain, and then you're going to start internal bleeding from any number of reasons because of being pulled apart on the rack. So those are different types of applications in physics, to where now when we think of a winch, okay, what might that possibly be? I mean, the highway patrol, they all have a winch on them, and it's on the front of their vehicle. Does anyone know what a winch does? Yeah, it has a cable attached to it, and it's got a little motor. And, well, I shouldn't say little, but you take that cable and you attach it to a vehicle that may be disabled in the ditch or something to that effect. You tie it on there, turn the winch on, wraps up and pulls them out. It's increasing something we call mechanical advantage. And what that does is it would move that vehicle. But anyway, when we're looking at this, the force is measured in newtons. As you can see, we have a mass in that acceleration. So let's put this to use, and we'll show you how these applications actually take place. And one of the, I want to say maybe the nice parts about this, okay, is the idea that the material that we've covered as far as formulas, they continue to build upon one another. Okay, so if this is our formula, okay, and I hope you have this wrote down somewhere, okay, we know what our force is measured in. What are forces measured in? Yeah, don't guess. It's something that you just wrote down. These are measured in newtons. These are measured in kilograms, and of course this is meters per second squared. And one of the aspects that I've seen on some of your problem solving parts of your exam, we're putting a velocity in for this, okay? And one of the ways that you can tell, if it's not the terminology, how you know you're not dealing with a velocity, but it's rather an acceleration. Because this is squared, and velocity is just meters per second. Okay, that's one of the things we just want to constantly be aware of. Okay, so with this, we'll say yes. If we get time, yes. They've been recorded. Okay, so okay, now I lost my train of thought. Well, we can just use this desk right here. In other words, what is the force on floor if a desk has a mass of, we'll say 80 pounds. So okay. Now, as you're looking at this, is there any outside forces acting upon this desk? Gravity is acting upon it. So there's a number that you need to utilize. It doesn't say that, but when we're dealing with forces, okay, well then sometimes you need to utilize gravity. If that's moving, well then you'd have to calculate the acceleration. But this, it gives it its weight. So we've read the problem. The next thing you should do is what? Okay, so what do we know in this problem? And then of course, we don't know. So to solve for that then, what do we do with those two numbers? We do what the formula tells you to do, and that is to take 9.8 times 42, and you probably get somewhere around 420, 411. And we label that in what? Newtons. That's right. Okay? Well, on a different scale, okay, who can we pick on in here? Okay, so Carly's one. Who's the other? Okay. So, can I erase this? Okay? So if you're choosing not to write these down, you're probably not helping yourself out. But if you have a good understanding of these, well then it's like in basketball late in the game, if you've got the lead and you're a good free throw shooter, chances are you're probably going to get fouled. Okay? And you just go up and you just keep doing what you're doing. You make free throw after free throw. Right? 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 Who doesn't like shooting free throws? Okay. Anyway, we'll get back to this. Okay, so you two young ladies, okay? In the boiler room, for some odd reason, we need some concrete busted out. So you need to pick between you two. One of you is going to hold the crowbar. The other one's going to swing the sledgehammer. Which one's which? Okay. Carly, you're swinging the sledgehammer. Okay? So, are you a good, can you hit your target? Okay, do you, you got trust in your worker? Who you're working with Carly? Carly, you're working with Jasmine? That didn't sound very confident. Okay. One of the things keep in mind is when many minerals were being, I want to say, ored or mined from the earth, the best way to do that would be to, you couldn't drill pilot holes. You just didn't have you just did not have the technology in the 1800s. So you probably had we had steel, so you had a bar, you had a sledgehammer, so you had to drive that bar down in there, let's say maybe a depth of 18 inches or so, start putting your dynamite in there, light it, and run as fast as you can. Okay? But one of the nice advances that dynamite was really stable, nitroglycerin wasn't. So probably a lot of people probably died because of that, because nitro was just so unstable. It was unpredictable. Then, has anyone ever heard of the Nobel Peace Prize. It's named after Alfred Nobel, who discovered dynamite. So one of the aspects with all, how does it say, with all of the atrocities that maybe take place on Earth, he wanted to put into a fund that people who try to bring peace to mankind, whether it's because of chemistry, physics, biology, the humanities, any one of them, you win the Nobel Peace Prize, and then you get a monetary gift and a very prestigious award. Does anyone ever follow the comedy of The Big Bang Theory? The series finale dealt with what? With Sheldon and Amy. Oh. They, in the show, they won the Nobel Peace Prize for super asymmetrical fluids. Okay, and that's way above and beyond what I would know. But anyway, get back to our construction workers here. Okay, so now I've seen Jasmine spelled because of students that I've had. Is that right? Is that right? Oh, you said just erase. I don't know why I erased both of them. Okay. What type of sledgehammer are we dealing with? We just got the little dinky 10-pound, or are we going to use a 30-pound sledge? 30 pounds. Yeah, that's probably pretty hard to swing, but we'll just keep it 10 pounds. So, but we're going to say it's a little bit bigger, 7.15 kilograms. Okay, there's a lot of words on here. Okay, so I'll go ahead and give you that chance to write this down. Okay. We see some familiar terms up there. The only one that is brand new would be that of force. Okay. So in that force formula, we see there are 3 variables. So what do we need to solve for the force then? What does it tell you? We need a mass and acceleration. So in this problem, what do we have to find the force? We only have how many variables? Just one. Now, this is a moving object. So upon doing that, it's not free falling, okay? So we're not using gravity. Okay? That's different than the application for this desk. We'll get better at that when you get more experience with this. So, the next thing we want you to do is what? Write down what we know. And what is that besides the mass? Mass equals 7.15 kilograms. I heard momentum, which is 55 kilograms dash meter over seconds. What else do we know? Do we know anything else? Okay. Okay. So, if our end result is trying to figure out what this is, okay, we need to find the force. We've got the mass, but we're missing this acceleration. But with all the information that we see here, is there something that we can solve for to get ourselves one step closer to solving for that force? What, if you know, what would that possibly be? What are we solving for? The acceleration. Because we need this variable here. Because you correctly told me we're looking for this, we have this, but we don't have an acceleration. But can we find the acceleration? And the answer is yes. So how would we go about doing that? What's your acceleration formula say? We don't have the final velocity. Okay? Minus the initial velocity, which is 0.50 divided by 0.50. Oh, 0.18. Okay. But do we see a problem with this? This equation is written correctly, but what's wrong with it? We've got two unknowns in here. So if we're still looking for this, we must be able to find this somehow. Okay? All right. So how are we going to find this final velocity then? Okay? So we're going to do what the momentum formula tells you, which is this guy right here. Okay? So we've got the mass, we've got the momentum, we can find that final velocity. So, upon doing that, we've got 55 equals our 7.15 VF. So how do we get that final velocity all by itself? Okay? We're going to divide each side by 7.15. So what is our final velocity? 7.69. Okay? Okay. So, left outside, are we on the bus? Left outside. Okay? Left middle. Middle. That means that we understand if we're on the bus. Okay? Left middle, are we on the bus? Or, excuse me, middle. Okay? You're following along? Okay. All right. So, right middle. Sorry, I'm coming from behind. Right middle. Yeah, right outside. Right outside? Okay. So, what are we going to do to find our acceleration now? Okay. So, since this is in parentheses, what do you do with these two numbers? Okay. So, 7.19. Does that sound right? So, Our acceleration equals 7.19 divided by what? What is our acceleration in meters per second squared? 39.95. So finally, we can solve for that force by doing what? 39.95. We're going to multiply that by what?
Mass, 7.15.
7.15. Okay. And what do we get? 285.7 what? Okay, 57 newtons. Okay? So hopefully we can see there's a lot that goes into this. The more exposure, the more you work on these, the better you will get at it. Okay? So, luckily, Jasmine, you still have your fingers. Carly didn't miss. That would be bad if you're holding this and you have that sledgehammer coming down and hits you in the fingers or in the hands, because it's going to break. It'll shatter a hand easily. Okay. So, anyway, any questions over this? If not, we're going to move forward. Left outside, are we good? Left middle, are we good? Middle? Right middle? Right outside. Right outside. Because everyone's saying they understand. So when you do that, we keep going. Should you have any questions, what can you do? You wouldn't be on the bus. Who has a really good understanding of this, do you think? I want to, okay. So for those of you who maybe don't really know for sure, see these people who have their hands up? I'm sure if you were polite and kind and asked them, I'm sure they would help you. All right. So that is where we will stop for today. We'll catch up to you next time. So next week, we'll probably have some more problem solving, and I'll assign the vocab. And we'll probably have your first problem solving worksheet that would involve material like this. All right. So that's next week.